Okay, then let's get into short run and the long run. Thereafter, we can get back into the returns to scale. What do we mean by short run? Any idea? What do we mean by short run? Those who have done economics, you can give the answer. What do we mean by short run? Not the economic sense, but in colloquial English, what do we mean by short run? Day-to-day life, short run. Is there any athletics here? Short run, it may be like, if you take athletics, it's like 100 meters, 200 meters, 400, 800. Those will be like short run. And long run may be like 1,500, 3,000 or marathon like. And if we take the time, it's like short run probably for someone, it may say like 10 minutes, 15 minutes or 1 minute, it's the short run. Long run maybe 10 years or 5 years or 10 more than 10 years and so on. So that is the short run in our day-to-day life. But in economics, when we say short run, it has a different meaning. Let me check. Okay, there are two answers. So one is within 1 year. Yes, within 1 year, we can say short run in day-to-day life, but not in economics, because in economics, in the production theory, when we say short run, we have a special meaning for that. We have one more closer answer. That is the time period that can only change labor factor in the production process. Because we learned there are many production factors, and in this case, for easy understanding, we put only two production factors, that is land and labor. So according to this answer, it says the time that only labor can be changed. Any other answers other than that? What is the short run in economics? Those who have done economics, we do that in our advanced level economy. Short run. When we say short run and long run, in economics, it is not about the distance. Like in athletics, 50 meters, 1 kilometer, or we have no any worries about the distance. And also we have no any worry about the time. Short run, it is not 1 day, 2 day, or 5 minutes and so on. It is about the production factors, how we can change. As one of our colleagues had mentioned there, it is about whether we can change our production factors or not. And so we term it variable inputs and fixed input. If we can change, we say variable input, and if we cannot, then we say fixed inputs. Right? So we are worrying about the type of the factor that we are getting in production process, whether it's a variable factor or fixed factor. Variable factor means we are the factor that we are changing, and fixed one we may not be changing. So here, short run means if we are having any number of production factors, at least, remember, at least one production factor will be fixed. It doesn't say that labor will be fixed or capital will be fixed. But whenever we are having a certain number of production factors, at least one factor will be fixed. That time is called the short run. So for that, let's take a simple example like Uvalas University. So when we started this university in 2006, we had only 147 students. We had 147 students, so we had block. We had ABC, 3 blocks, as well as the administrative building. That is the only, those are the only buildings we had at Uvalas University. So fixing these buildings the same, we started with 147, and we had like 25 lecturers and some administrative staff. and some security, cleaning service, and so on. Then what happened? Next year we got another 150. Next year we got like 450, and thereafter number was increasing. So number of students got up to like 1,000 students. Then what we felt? We felt we cannot keep our space fixed. Up to now, we are getting into 10,000 students. It was fixed. The space was fixed. And what we changed? We changed number of students. In the beginning, it is 147, and then 300, 500, and up to 1,000. We changed the number of students, and we changed the number of staff. We change the amount of electricity that we are using. All these are known as variable inputs because we can change. We can change number of students, we can change number of teachers, number of computers, number of security personnel, and so on. So we could change all these, but not the space, the buildings. So it is known as the short run. So for OLS University, short run in that case was like 5 years. Then what happened? Then we found, okay, more than 1,000 students, we cannot accommodate any other students in the university, more than 1,000 students. And the space was not enough. Then what we did, we changed the number of buildings. Right? So we had new buildings built like Block D, E, and this garment factory, G block. Right? So by changing that, what happened? We moved into long run. Up to that point, we were in the short run, and when we increased the number of buildings or space, then we got into long run because all the variable could be changed. So therefore, the time until we change the buildings, we are in the short run. At the time when we change our building, then we move into long run because the definition of the long run is that there is no any fixed input. In the long run, there is no any fixed input. We can change any input. In the short run, there will be at least one fixed input. And our university is a very good example how we evolve. So we started with new space with 1,000 students, and then we kept the same space and increased the number of students to 1,500, 2,000. So that was again the short run. At the end of that, we found again, if you want to increase more students, we need more space. So again, we increase our space by building F block, technology building, and so on. Right? So by increasing the number of buildings, what we did, we got into the long run again. And in that long run, after some time, we started by getting another 2,500 students, then 3,000 students. Now we feel, again, our space is limited. So with that, what I wanted to mention, there are two things. One is the short run. That is the time where we are having at least one fixed input. Then we are having the long run. That is the time where we can change all our production factors. The time that we can change all our production factors is known as long run. And the time there will be at least one fixed input is known as the short run. One more thing I just wanted to highlight. See, if you look at my cafeteria example, you understand that long run means it's kind of a combination of short run. Like Uvila's case, we had 0 to 1,000 students, one short run. And then we changed everything. So it became long run. And in that long run, we had like another 2,000 students. Right? It was kind of a short run for that period. Then we enhance our space. And then we got into one more long run, short run. And therefore, we say a long run is a combination of short run. I will come back to this point later, but just remember for the moment, in a long run, there will be several short runs. And short run means there will be at least one fixed input. Long run means there will not be any fixed input. And this one, we are familiar with that. This is the production function. Q is a function of capital and labor. If you look at this, Q is a function of capital and labor and the function that we learn. Maybe I will write it here. This is the production function we were discussing. Output is a function of capital and labor. Then now we are having the short run production function like this. Output is a function of capital and labor. Can anyone see a difference between these two? Of course, my handwriting is different because this is not clear. Output is a function of capital and labor. Okay. Any difference between these two equations? Can anyone figure it out? This is the short run. In fact, this one we have not discussed yet about the long run, but generic form is like this, function of capital and labor. If you look at these two, let's say this is equation 1 and this is equation 2. If you are looking at equation 1 and 2, what is the difference between these two equations? Any difference? If you look at here, yes. So if you look at here, you can see bar. Right? Instead of K, we have K bar in this case. And there's a bar top of K. So we say, yes, as let me check who provided that. Yes, capital is fixed in the second function. In fact, it is with the first function. If you look at here, you can see the first function, this one, the short run, K is fixed because we have a bar here. This says K is fixed. So we are in the short run because in this case, we are having only two production factors. Out of these two production factors, one production factor is fixed. And in that case, we say it is the short run. But in the production function, you can see here, both capital and labor, both are variable or variant. Right? We can change both of them. Then it is known as the long run. That is the difference between the generic function we checked previously and this one. Right. So the total production function in the short run can be set like this. Then using this total production function, we can define the marginal production function, which we defined in the previous class, the marginal. What is the meaning of marginal in economics? Marginal means value for the next unit. When you increase something, what will happen? If you increase your number of output, then you are checking what is happening to my profit, which is known as marginal profit. On the other hand, you can increase one more labor unit, the employment of one more labor unit. Then we can get marginal product of labor. That is the value for next unit of increasing labor. So we discussed this one. Then we can measure that easily. That is the change in Q divided by change in L. We say delta Q by delta L. So in the short run, we are having only one variable input. Therefore, we are having MPL, marginal product of labor, which can be taken by delta Q by delta L. Or some of you are very good in mathematics and now you have done mathematics. So this is the slope of the production function. So therefore, we can get easily if you get the first order derivatives of the production function. Like if you want to get the first order derivatives of the production function with respect to L, we are having only L in the short run as a variable input. Therefore, if we get the first order derivatives of the production function with respect to L, you easily get MPL or marginal product of labor. And then we have the average production. As we previously discussed, it is simple. It is just the mean of the, it is the output per one labor unit. In the short run, we are having one labor as our production inputs. Therefore, what we do, we get the number of total output level divided by the number of labor units. Then we are getting average production. This average production, marginal production, and total production can be again shown in a graph like this. Previously, to understand the substitutability, I use one table. This is similar kind of a table where we are having labor will be moving from 0 to 1, 2, 3, 4 up to 8. And capital, of course, now it is different. Right? So we are having only 5. It is fixed. So we say this is the short run, therefore capital is fixed. Capital is fixed at 5. Then using the functional form, we have taken the total product. Total product goes like 0, 20, 50, 90, like up to 150. And this is the marginal product. That is the difference between the total product of unit 2 and the product of unit 1. Simply we say incremental value. What is the total contribution? So what is the contribution that we add to the total production by increasing one more labor unit? So we are increasing from 0 to 1, then marginal product is 20 because the next labor contributes 20 units as the at his or her production. This is known as marginal production, which is taken like this. And then we are having average product. It is simple. That is the total product divided by number of labor. Then you are getting the average product. So this table, exactly like the previous table we discussed in the previous class, only difference now K is fixed. So because of this K is fixed or capital is fixed or at least one fixed input, we have a different behavior in our production function, which can be shown like this. So this is the behavior of the total production function. So it will be increasing at an increasing rate and then increasing at a decreasing rate and then it will be decreasing. So this is the shape of the production function in the short run. This shape, it is very practical. Right? It is very practical and maybe easy if you remember with the concept. So I just give you one simple example. I hope you visited the university and you were here for 3 weeks. Then probably you have been to our cafeteria. In our cafeteria, we have the photocopy center where we are having, let's say, 3 photocopy machines. There are 3 photocopy machines in our cafeteria, and we have the room and toners, papers, and everything is there. Other than labor, and there is no any labor. What could be the output? What could be the number of photocopies if we are having 3 computers and 0 labor? What is the output? What could have been? What could be the output if we are having 3 photocopy machines and everything and 0 labor? There is no any labor. It is like during the corona pandemic. Right? We had no labor, but we had all these machines there. What is the output? Expected output? Any idea? If you look at this table, you can see it is like 5K. Let's say this is 5 photocopy machines. 0 labor. What is the total output? It is 0. Because there is no any production without any labor. To produce anything, we need labor. Already we have fixed capital. That is true. We are having space. Right? So fixed capital already we have borne, and some of the variable inputs also already given, like the photocopy machines, toners, and papers, and so on. But there is no any labor. As far as there is no any labor, our output will be 0. Then what happens if we put one more labor? So we are having 3 photocopy machines and 1 labor now. What happens? There will be a certain level of production output or number of photocopies per hour, depending on the capability of the person, but there will be certain amount. So 1 labor and 3 photocopy machines. Let's say we are getting like 100 papers. Then we add 1 more. We had 1 labor, so we put 1 more labor as 2. Then what happened? If the first case output was 100, the second case output will be more than 200, because the additional worker will not generate like 100 like the previous case. He will be generating more than that. Why it is? It is very practical, because before getting into 2 persons, a single person, what he did, he copied and took money and went to Batulla city and bought all these items and so on, and came back. Likewise, he did everything by himself. But now we are having 2 people. Therefore, 1 person dedicatedly will be working on the machine. The other one, time to time work in the machine and then work with the customer and so on. Therefore, output will be increased more than the previous. When we put the third worker, it is also still the same. Now we have 3 machines, 3 people. And time to time, 1 person get to the customer and continue working, and someone will get into Badulla city and buy all these required items and get to the photocopy center. So therefore, third case, output will be increased more than the second one. When we put the fourth one, now we have 3 dedicated labors and 3 photocopy machines. So all the photocopy machine is having 1 dedicated worker. And the fourth one, what he will do, he will be taking money and giving printouts and working with the customer and logistic work and getting to city and bringing all these items will be done by that fourth guy. So therefore, output will be increased more than even the previous. And because we are having 1 dedicated guy for each machine and 1 guy for all the other work. When we put the 5th one, what will happen? When we put the 5th one, output will be increased, but that increase definitely be less than the increase in the previous case when we put the 4th one, because now we are having 3 people dedicated for machines, 1 dedicated for the customer service. So what 5th one do? He will have to share some of the work. Whenever get a free time, 5th worker will be doing his or her work. So output will be increased, but not like the previous. Let's assume we are putting the 6th one, or 7th one, or 8th one. Then what will happen? They may not be generating that much of output. Instead of that, now they have no work, they have nothing to do much. So what they do, they will start talking and wasting time. And even that will decrease the production of those efficient workers, because now they have to speak. Right? There will be a person who is having not any work, so he will be starting talking. Likewise, when we put 7th, 8th, 9th, and 10th, output will be increasing, but it is not like the previous case. And when you put 10, 15 people then the production also may get affected. right? Not efficient. Now the workers cannot work because they are talking a lot. They listen answers and therefore output will be decreased. And if we are going to fill the room with one more workers, we put 15, 30, 100, 200, then there will be a day where we are totally filling the room with workers. Then this total production even can touch, theoretically, even can touch the labor axis or zero output. So we will be getting zero output by increasing one more labor, because there will not be any enough space for workers to work. The whole room will be filled by the people. So this example clearly says in the beginning of the production process, there will be increasing output. When we increase our inputs with the same amount, our output will be increasing continuously. And also, the improvement in the total product is higher than the previous case. The adding amount to the total product by a new worker is higher than the adding of the previous case. So we say output is increasing at an increasing rate. But after that, when we put fifth labor, sixth labor, and seventh labor, then output will be increasing, but not like the previous. Right? So we say output will be increasing at an increasing rate in the beginning. Thereafter, it will be increasing at a decreasing rate. So if we continue further, it will start decreasing, like the case in our case, like having more than 10, 12 workers for 3 photocopy machines, which even can go up to zero production. So that example clearly shows the behavior of the total production. The behavior of the total production is like this. Then why we are having this kind of a behavior in the short run? Any reason why we are having this type of a behavior? At the beginning, it will be increasing at an increasing rate. Thereafter, it will be increasing at a decreasing rate, and then it will be decreasing. Any special reason for that? That can be explained with something called law of variable proportion. Law of variable proportion. Law of variable proportion says the amount of variable input, that can be absorbed by the fixed input has a limitation. So variable proportion says if we keep one production factor fixed, and if you are increasing the other production factor or factors, the amount of these other production factors could be observed by the fixed input will have a limitation. So this is the reason why when you continuously increasing your input, output will not be increased like the previous case. It has reached to its limit. In our case, we had 3 photocopy machines, so the capacity is 4. When we are having 4 people, of course, that 3 photocopy machines will absorb 4 people nicely. Therefore, output will be higher for that section. But if you keep your fixed input the same and continue to increase the variable input, like the 5th, 6th, and 7th unit in our case, then that fixed input cannot absorb that much of variable inputs. Therefore, output will not be increased like that. That is true for any production process. If you just take the simple example, the paddy farmer near my village, it has a limitations. So the paddy field is the fixed input. We can take 1 guy, so he will be nicely working. 2 guys, then a bit more than that. Then the 3rd, 4th, like up to 20, of course, output will be increased. Whenever we increase the number of labor units, output will be increased. But When you put more than 20, or let's say 21, then there will not be any improvement because the additional guy will not be generating that much. Right? This happens because of the law of variable proportion. Simply it says amount of fixed input that could be absorbed by the amount of variable inputs that could be absorbed by the fixed input has a limitation. This is why we have this kind of behavior in the total production function in the short run. Then marginal product means value for the next unit. If you look at this one, you can see value for the next unit. In the short run, it is increasing. It was 20, 30, 40. Right? So when we increase the number of labor, our total output is increasing. And marginal output also increasing. But after some time, it will start decreasing. So here you can see then it will be again 30, 20, 10, 5, even it can go negative. So in this case even it may go negative. So marginal product in the short run, it will be increasing and get into a kind of a peak and decreasing. Average product, that is also the same. We can get back to the table here. Average product, it is 20, 25, 30. So it was increasing. And after that, it is 30, 28, 25. So it will be decreasing, but it will never get into zero because the behavior is like this. We have some value divided by the labor. So one fixed value divided by labor, the constant divided by labor will behave something like this. And so this is the behavior of the average product curve in the short run. Suppose these three are very simple, but if you put all these graphs together like this, we can make the relationship between total product, marginal product, and average product. So this is the total product curve in the short run. It is increasing at an increasing rate in the beginning, and then increasing at a decreasing rate in the thereafter, and then it will be decreasing. So you can see here three stages: stage 1, stage 2, and stage 3. Right? Stage 1, this marginal product will be increasing, and it will be increasing and start decreasing. At the end of the stage 2, we see that marginal product is decreasing, but average product get into the maximum. Therefore, the maximum point of average product will be cut through by the marginal product and moving down. And then marginal product will get into zero or touching the labor axis. So that is the point where we are having the peak point in the total production function. So remember these relationships, these are important because when we are going to discuss with the cost functions, we need these relationships. So depending on these relationships, we decide our optimum output level, because the meaning of this analysis, why we need this analysis is that we need to decide on the optimum output level such that we get maximize our profit. So therefore, these relations are very important and they will convert into cost functions, which we will be discussing later. Now, because of that, because of this profit maximizing output level, I have a very simple question, which may not be, that much interested. But if you take this stage 1, stage 2, and stage 3, at this stage we need to stop our production. Should we stop our production at stage I by putting stage 1 by putting this much of labor, this much of labor, this much labor, or at least this much of labor until here. Should we do that? Because our output level will depend on the number of labor. So by changing the number of labor, we can change the total output level. So we can put, let's say, 0 to a number of labor, or A to B, somewhere between A and B. We should decide our level of output, or beyond A, that is B, that is this much of labor. If our objective is profit maximizing, where should we stop our production? Any idea? Where should we stop our production? Stage 1, 2, 3. Now, if you are putting, later we will discuss this under cost, but if you are putting here one more labor, what happens? So we have certain level of output. When we put 2 labors, then our output will be increased more than that. But we are putting only 1 labor. So we had 1 labor here, 1 labor here. This output was 10. Here output is 12. Therefore, what happened? If you take cost, this is 100 rupee, let's assume, this is 200 rupee. Cost is the same. If you are increasing 1 more unit to your production, your cost will be same. Therefore, when we increase one by one our the amount of inputs that we are using, our cost will be increased with the same amount. But what happens to your output? Output will be increased more than the previous. Therefore, value of output is higher. Therefore, if you are producing any point here, your output will be increasing more than the effort, more than the cost. Therefore, it is better to move this way, ne? Somewhere here. Because when you increase your labor units, your output will be increased more than that. If you take stage 3, what happens? In stage 3, when you increase your labor unit by 1, so now you are increasing 1, and your output will be increased less than the previous. It is decreasing. Therefore, your cost will be higher than your additional cost will be higher than the additional gain, which we say marginal cost will be higher than marginal revenue. Therefore, it is better to decrease your output. Right? So stage 1 and stage 2 will not have any solution, because in stage 1 it is better to increase the output. Stage 2 it is better to decrease the output. Therefore, if you are a rational firm, you will be deciding your output in stage 3. The number of labor units here will depend on stage 2. But we will be having some discussions later when we are doing the cost function. Just I want to highlight that, because these relationships are important when we are going to discuss with the cost functions. Now, as I just said, the stage 2 will have the optimum output level, optimum number of labor with the profit maximizing output level. Now we need to see how to decide that. How to decide at which place, here or here, here or there. Stage 2 is okay, but at which place? That can be discussed under this optimum employment of factors. How we are going to employ our production factors, how much factor.